Hi, today we're going to talk about exponential functions. Let's see if I can talk English. Alright, just like with linear and quadratic functions, we want to know what the parent function is. And so for exponentials, that's y equals b to the x. Now it's important to note b is any number, so 3, 2, 9.5, whatever. So b, you might want to make a note to yourself. B is just any number. Well, it would be good to know what this function would look like. And it's going to look a little funny. It's going to look something, oh, I don't like that. It's going to look something like this. Here we go. That's not bad. So it's going to look like that. Alright. And our domain, so again, thinking about domain, look to the left. Does it end? Nope. Look to the right. Does it end? Nope. So that means it goes on forever and ever in both directions. So x is in the set of all real numbers. I'm sure you've gotten tired of hearing that. For the range, well, this is a little different. If you notice, this gets really close to the x-axis. Like, crazy close. And so we can draw this imaginary line that should be right on top of the x-axis, and that line is called the asymptote. Yes, funny word. It sounds like a bad word at the front, asymptote. So that asymptote, that means that this line is going to get so close to our x-axis, but it's never actually going to touch it. So that means our range, it has to be above the x-axis, and our x-axis is when y equals 0. And it goes forever up, but it stops before y equals 0. So that means y can be greater than 0. It cannot be equal to. It cannot. Because it's going to get very close to y equals 0, but it's never going to quite touch it. That's what asymptote means, is it's going to get really close to this line, but it's never going to quite touch. Okay, just like before with linear and quadratics, let's talk about representations. So for the equation, your x is going to be the exponent, like we see here. Notice how x is the exponent. It's not down here. It's up in the air. It's the exponent. Graphically, we have two different kinds of graphs. We could have something that looks like this. I hope y'all like my pretty pink pen. I know I like it. Or it could go the other way. Looks something like this. Alright, and you're going to hear about this in biology. I can basically guarantee it. That first graph, we call that growth. So going from left to right, if your graph is increasing, it's growth. If going from left to right it's decreasing, we call that decay. And you'll hear about those definitely in biology, and I know, I'm pretty sure in chemistry you'll talk about decay as well. Alright, we got to talk about tables. Alright, so here's our table. We got 1, 2, 3, 4. Let's say our y's are 2, 6, 18, 54. No, those numbers got big fast. So here's what hopefully you'll see. So going from 2 to 6, we multiplied by 3. From going 6 to 18, we multiplied by 3. And going 18 to 54, I hope my math is right, we multiplied by 3. So notice, that's our common ratio. 3 is our common ratio. Oops, I meant to write this down on my line. So it has a common ratio. That means we're not adding or subtracting something each time, we're multiplying by something each time. That's a common ratio. Alright, we have one example. If you have any questions, I know I'm not in school today. Oops. I guess I didn't realize I cut off my own email address. Oh well, I'll put that at the end of the video. So if you have questions, you can email me. I'll put my email address at the end of this video. All right, here's our example graph. Lovely, lovely graph. Something I want to point out is here's our line at y equals 1. Notice our graph gets really, really close to that, but never touches it. That'll come in handy in just a little bit. All right, let's look at domain. So that's our x's. So ask yourself, is there a point to the left where this ends? Nope, it goes on forever and ever to the left. Okay, what about to the right? Is there a point to the right where this ends? Nope, it goes forever and ever to the right. So that means our domain is x is in the set of all real numbers. Fabulous. That was easy. Y is a little harder. So y, we got to ask, is there a point going down for our range? Is there a point going down where it stops? Well, yeah, it never, here's our asymptote. Again, good word to know, asymptote. It never quite reaches y equals 1. It's going to get really close, but it's never going to equal 1. And then going up, it should be easy to see. It goes up forever and ever. So that means y has to be greater than 1 because it gets really close to 1 but never touches it, and it's above. If it was down here, we'd have less than, but it's not going down. It's above our y equals 1 line. So y has to be greater than 1. All right, that's it for the notes. If you have questions, email me since I'm not in class. Then you have some practice to do. Feel free to work with a partner, but once you leave class today, the rest has to be done on your own.